Black holes are easy to fear. That is part of their power. They give terror a geometry. A region of darkness so absolute that even light cannot return. A horizon that functions like a sentence. A one-way border written into spacetime itself. A place where matter vanishes from sight and our equations begin to sound less like explanation. And more like warning. If the universe wanted to hand the human imagination a perfect symbol of cosmic danger, it is difficult to improve on a black hole. It is the abyss, but quantified. It is mythology with tensor calculus. It is a grave, a prison, a wound, and a question, all at once. And yet there is a trap hidden in how much black holes frighten us. The things we fear most easily are not always the things we should fear most deeply. Again and again, reality humiliates the first draft of terror. The obvious threat is often not the most profound one. The thing that looks violent is not always worse than the thing that quietly rewrites the conditions under which violence, memory, causality, and explanation even make sense. That is the direction we are going tonight. Not toward a bigger monster. Not toward a newly detected object with a more dramatic name. Not toward science fiction disguised as cosmology. Toward something colder. Because what may be worse than black holes is not necessarily another object in space. It may be a class of structural threats built into reality itself. Threats to predictability. Threats to information. Threats to shared future. Threats to the vacuum beneath all ordinary matter. Threats to the long-term possibility of complexity. Threats to the universe remaining a place in which causes still lead to effects in ways we can meaningfully trace, in which evidence remains available, in which the future remains connected. Enough to still count as one common world. A black hole can destroy a spacecraft. It can dismantle a star. It can reduce ordinary rescue to fantasy. But there are ideas in modern physics and cosmology that do something more unnerving than destruction. They threaten the rules that make destruction describable. They threaten the bookkeeping of the universe. They threaten whether information is truly safe. They threaten whether the vacuum we call empty space is genuinely final. They threaten whether the cosmos can go on supporting useful energy, complex structure, and explanatory access. They threaten whether more and more of the universe simply slips forever outside the possibility of relation. A black hole is visible terror. The deeper horrors are not always visible. Some are thermodynamic. Some are cosmological. Some are quantum. Some are not explosive at all. Some arrive with no warning. Some unfold so slowly that the imagination fails to register them. Some are not events in the usual sense, but conditions. And the most disturbing of them all may not kill us violently. They may erase the circumstances under which worlds like ours remain possible. That is why this story matters. Because fear changes when it stops being about bodies and starts being about structure. The deepest danger may not be being swallowed. It may be being cut off. Or thermally exhausted. Or rewritten. Or made causally irrelevant. Or discovered to rest on a vacuum that was never truly secure. Or trapped inside a universe whose future preserves existence while withdrawing connection. That is harder to picture than a black hole. And because it is harder to picture, it is easier to underestimate. But physics has been moving in this direction for a long time. Over the past century, the gravest conceptual shocks have not come only from violent things. They have come from horizons. Singularities, entropy, quantum information, vacuum structure, and cosmic expansion. They have come from learning that the universe's deepest risks may not be claws in the dark. They may be invisible revisions to the terms of existence. So get comfortable. Because by the end of this documentary, black holes may no longer look like the darkest thing in the cosmos. They may look like the last honest terror. The last great danger that still had the decency to show you its face. Before we go any further, we need to disarm the title. Physicists have not found a single confirmed cosmic object and placed it in a ranking above black holes with a label that reads, "This is worse." There is no official nightmare catalog. There is no press release announcing that an even more terrifying thing has been photographed in deep space. That is not what this documentary means. What it means is subtler, and in some ways more severe. Modern physics has gradually revealed that the gravest threats in the universe are not always object-like. They are not always local. They are not always violent in the way the nervous system expects. Very often, the most disturbing possibilities arise not from things that smash matter, but from features of reality that undermine relation, intelligibility, stability, and lawful continuity. That is a different category of fear. A black hole belongs to a category the human mind still understands surprisingly well. It is somewhere. It can be represented. It has a silhouette. It creates a dramatic local danger. You can point to it on a map of a galaxy and say, "There." That is the problem. Even when the physics becomes advanced, the emotional structure stays old. A black hole is a cliff edge scaled up into cosmology. A line beyond which return fails. But not every danger in physics works like that. Heat death is not a place you can point to. Vacuum metastability is not a place you can point to. Cosmic event horizons are not a place you can point to in the ordinary way. The information paradox is not a place you can point to. The loss of future observability is not a place you can point to. The possibility that our current vacuum is only a local minimum and not the true ground state of reality is not a beast with coordinates. And yet any of these may, in the right sense, deserve more fear than a black hole. Not because they are more cinematic. Because they are more structural. That word will guide everything from here onward. A structural threat is worse than an object threat because an object still acts inside a world whose rules remain intact. A structural threat attacks the conditions that make the world cohere. A collapsing star is violent, but it still obeys law. A black hole is extreme, but it remains a local feature of a lawful universe. A structural catastrophe is different. It threatens causality, predictability, information preservation, long-term access, or the stability of the vacuum itself. One destroys contents. The other threatens the container. Or more precisely, it threatens the assumption that reality is a stable stage with durable rules. And that is why black holes may be the wrong thing to fear most. They dominate imagination. Because they remain visible enough to monopolize dread. They feel like maximum danger because they satisfy old instincts. But the deeper we look into modern physics, the more we find that the worst possibilities are not visible monsters. They are changes in the terms on which existence remains comprehensible. To see this clearly, we need to separate three kinds of claim. First, there is established science. Black holes exist. General relativity describes horizons as serious features of spacetime. The universe is expanding. That expansion is accelerating. Entropy governs the direction of thermodynamic change. Information is not a vague philosophical extra in modern physics. It is fundamental to how we think about states, evolution, and consistency. Classical singularities indicate that our best classical theory reaches regions where it is no longer sufficient. Second, there are serious open problems and active areas of research. How black hole evaporation preserves information. Whether and how quantum gravity resolves singularities. How horizon thermodynamics reveals the microscopic structure of spacetime. Whether our vacuum is absolutely stable or metastable under known parameter extrapolations. How cosmic acceleration shapes the long-term future of accessible reality. These are not fringe anxieties. They are mainstream frontier questions. Third, there are more speculative scenarios. A guaranteed false vacuum decay event in our future. A big rip. Boltzmann brains dominating the far future in some cosmological measure. Generic naked singularities in nature. A final complete theory of quantum gravity we can state with confidence today. These matter, but they do not carry the same evidential weight as the first two categories. That distinction is essential. Because a disciplined fear of reality is more interesting than sensational panic. This documentary is not here to inflate every cosmic possibility into apocalypse. It is here to show that even the disciplined version is enough. Once you understand what physics is actually saying, you do not need exaggeration. The universe is already severe enough. A black hole can end a body. A structural threat can end a framework. A black hole can destroy locally. A structural threat can alter what remains globally possible. A black hole can hide a region behind a horizon. Cosmic acceleration can hide entire futures. A black hole can challenge our theories. The information paradox challenges whether the universe preserves coherent accounts of its own history. Heat death can starve the future of free energy. Vacuum decay, if the vacuum is metastable and transition occurs, would not merely destroy objects. It would replace the effective rules by which ordinary matter exists. These are not all equally likely. But they belong to a family of thought that black holes prepare us for without exhausting. And that family has a common theme. The most frightening possibilities in physics are often not about pain. They are about the withdrawal of structure. The withdrawal of shared future. The withdrawal of predictability. The withdrawal of usable gradients. The withdrawal of lawful transparency. The withdrawal of access. The withdrawal of stable background conditions. Black holes are easy to fear because they look like danger should look. The universe may be hiding worse things because the deepest dangers do not always advertise themselves that way. They can be patient. They can be cold. They can be mathematically quiet. They can be invisible until you understand what they imply. So we begin where fear begins best, with the thing we can picture. The thing that still gives terror a shape. Because only after we understand why black holes dominate the imagination can we understand what it would mean for something to be worse than them. Human beings fear best when fear has contour. A ledge. A mouth. A storm wall. A predator's outline in low light. A door that closes behind you. The nervous system likes geometry. It likes direction. It likes a threshold beyond which life becomes harder or impossible. Even our myths follow this pattern. Rivers no one returns from. Gates between worlds. Pits that symbolize descent into states from which ordinary rescue fails. Black holes inherit all of these instincts at once. They are the rare scientific object that feels as if it was designed by the ancient part of the mind. And then signed off by Einstein. They take abstract theory and produce an image that seems instantly legible even to people who know no tensor calculus at all. That image matters. A dark center. A ring of distorted light. Matter spiraling inward. A horizon beyond which return disappears. It is not merely scientifically powerful. It is psychologically exact. A neutron star is extraordinary, but it does not carry the same symbolic perfection. Dark matter is profound, but it offers no obvious visual grammar. The cosmological constant may be among the deepest problems in modern physics, but it does not lodge in the imagination as a clean wound-in The sky. Black holes do. They dominate the imagination not only because they are dangerous, but because they are narratively obedient. They look like what danger should look like. They turn abstract gravity into an icon. Then there is the emotional compression they achieve. A black hole fuses multiple human anxieties into a single object. It is about death, because there is a no-return boundary. It is about blindness, because light itself fails to escape. It is about helplessness, because no ordinary act of will or machinery rescues you once past the relevant threshold. It is about time, because relativity makes different observers describe infall and horizon approach in counterintuitive ways. It is about ignorance, because the interior is hidden from outside description in a principled sense. It is about theory, because singular behavior and evaporation push our frameworks into conflict. It is about identity, because what falls in seems stripped of ordinary descriptive richness from the outside. No wonder black holes took over popular science and science fiction alike. They are not merely astrophysical. They are existentially overqualified. And importantly, they frighten both lay imagination and professional physics. That overlap is rare. Many things terrify physicists without terrifying the public. A non-unitary evolution law, an unremovable gauge anomaly, a violation of cherished symmetry principles, a bad ultraviolet completion, these matter deeply but do not animate ordinary dread. Many things terrify the public without terrifying physicists. Apocalyptic imagery, misunderstood. Astronomy, dramatic but harmless cosmic alignments, speculations with no empirical basis. Black holes strike both. They are cinematic enough for instinct and rigorous enough for theory. But there is a hidden comfort in that. Visible terrors can be psychologically contained. We know where to place them. Even when we cannot survive them, we can narrate them. A visible danger sits in the world as an object of fear. It lets the mind say, there is the problem. That containment is more soothing than it first appears. The deeper dangers in physics resist it. You cannot easily point to entropy. You cannot easily point to cosmic horizon loss. You cannot point to the vacuum's possible metastability in the same way you point to a black hole. You cannot draw the gradual thermodynamic exhaustion of usable energy as cleanly as an event horizon. You cannot give the crisis of reality's bookkeeping a silhouette. And because you cannot, they tend to slip past emotional attention. This is why black holes may monopolize fear without deserving a monopoly on depth. They are what the mind reaches for because they remain legible. A black hole is still a thing. However severe, it belongs to the category of located terror. But modern physics has been teaching us a harsher lesson for a long time, some of the greatest threats are not things at all. They are failures or limits of relation, predictability, access, stability, and lawful continuity. They are threats that live in the grammar of the universe, not in one dramatic noun. And that means black holes may function less as the final horror and more as training. They teach us how to fear horizons. How to fear hidden interiors. How to fear one-way structure. How to fear the boundary beyond which ordinary intuition ceases to guide. Then, once we have learned that, physics asks us to go further. To fear not only the visible abyss, but the invisible conditions that made the abyss possible. Not only the object, but the rule. Not only the fall, but the universe in which falling can become one way at all. That is a much colder education. Because the thing that can be pictured is often not the thing that reaches deepest into the architecture of reality. Still, before we move on, black holes deserve honesty. If we are going to argue that something may be worse than them, we must grant them their full severity. We must strip away the pop culture distortion, keep the genuine wonder and terror, and ask what they really are. Only then can we measure anything against them fairly. Let us be fair to black holes. They are not overrated. They are misframed. A black hole is not terrifying because it is a cosmic vacuum cleaner sucking in everything from arbitrary distances. It is not a magical mouth roaming the galaxy with indiscriminate appetite. It is not a hole in space in the simple visual sense. It is not a portal proven to lead elsewhere. And it is not merely an object with very strong gravity, though that phrase is commonly used. A black hole is more precise and more disturbing than that. In general relativity, a black hole is a region of spacetime containing an event horizon, a boundary, such that events inside cannot send signals to faraway observers outside. That is the essential structure. The horror is not just strength. It is causal architecture. This matters. A dense star can pull powerfully, but outward trajectories remain available. A black hole changes the menu of possible futures. Inside the horizon, away, in the familiar escape sense, is no longer part of the future-directed options. The geometry of spacetime itself has been bent so strongly that escape ceases to be meaningful in the old way. That is why black holes are not just heavy things. They are rearrangements of possibility. This already gives them unusual philosophical weight. Most dangerous objects in the universe are dangerous because of what they do to matter. Black holes are dangerous because of what they do to spacetime's causal structure. And yet what makes them even more extraordinary is that they are not hypothetical in the broad sense anymore. We have compelling evidence for stellar mass black holes from the deaths of massive stars, for supermassive black holes at the centers of galaxies, for black hole mergers through gravitational wave detections, and for horizon-scale environments through imaging techniques such as the Event Horizon Telescope. We no longer discuss them as exotic mathematical curiosities. They are there. The universe makes them. And when the universe makes them, several layers of terror stack together. First, the astrophysical layer. Matter falling into a black hole can be heated to extraordinary energies in accretion disks. Tidal forces near some black holes can become catastrophic. Entire stars can be shredded in tidal disruption events. Mergers of black holes release gravitational radiation with astonishing power. These are not gentle phenomena. Second, the relativistic layer. Black holes bring time and geometry into regimes that defy everyday intuition. External observers describe infall differently from infalling observers. Clock rates diverge. The relation between local experience and global description becomes strange. The black hole does not merely threaten survival. It threatens the simple, unified picture of events we instinctively want. Third, the thermodynamic layer. Black holes possess entropy proportional to horizon area. That fact, first sharpened by Bekenstein and Hawking, revealed something astonishing: horizons are not mere geometric decorations. They seem tied to deep microphysical counting. A black hole has temperature. It radiates. It can, in principle, evaporate. This is the point where visible terror becomes theoretical terror. Because once black holes radiate, questions arise. What exactly is a black hole counting when it counts entropy? Where is that information stored? How does evaporation preserve quantum consistency? What is the microscopic structure behind horizon thermodynamics? Does spacetime itself have underlying degrees of freedom we do not yet fully understand? That is when black holes stop being simply dangerous and become diagnostic. They are not just objects that kill. They are stress tests for law. And then there is the singularity issue, or at least what the classical theory points toward. General relativity, followed inward under certain assumptions, leads toward singular behavior. Most physicists do not believe that classical singularities, understood naively, are the final truth. But their appearance means something serious. Our classical description reaches a regime where it cannot continue without breakdown. That is not merely an engineering problem. It means that the very object that frightens us visually also points to the incompleteness of our deepest current frameworks. No wonder black holes dominate imagination. They do everything. They satisfy instinct. Astrophysics, relativity, thermodynamics, and foundational anxiety in one place. But this is also why they risk hiding the deeper story. Because black holes are still local. They occur somewhere. They have boundaries. They can be modeled as regions or solutions. They can be confronted conceptually as objects in a broader universe. The deeper threats often do not grant us that convenience. If information preservation is at stake, the problem is not a place. If heat death governs the future, the problem is not a place. If the vacuum is metastable, the problem is not a place. If cosmic acceleration severs future access to most of the universe, the problem is not a place. The black hole remains terrifying, yes. But it remains terrifying in a form the mind can hold. It is visible horror. The rest of this documentary is about a harder category. Invisible revision. Still, before leaving black holes behind as a frame, we should recognize what they teach us. They teach that the universe's gravest dangers are not always about force or temperature or impact. They can be about how the structure of causality changes. They can be about whether information survives. They can be about whether our current laws remain whole under extremity. In other words, black holes are not only terror. They are instruction. They teach us how to fear what cannot be reduced to collision. And that is the perfect transition, because the next step is the difference between how human beings rank danger and how physics ranks it. Human beings fear pain and death. Physics fears inconsistency. And in some contexts, inconsistency is worse. The hierarchy of human fear is obvious. We fear injury, loss, pain, starvation, suffocation, the collapse of the world at the scale of bodies and relationships. Physics has a different hierarchy. Physics can tolerate devastation as long as devastation happens lawfully. Stars may explode. Galaxies may collide. Planets may freeze. Civilizations may vanish. Black holes may swallow. All of that is tragic in human terms and yet, from the standpoint of physical law, acceptable. A universe full of catastrophe can still be a consistent universe. What physics cannot tolerate for long is contradiction. This is why so many of the deepest crises in theoretical physics sound emotionally dry. Nonunitarity. Divergence. Gauge inconsistency. Pathological singular evolution. Horizon. Paradoxes. Vacuum instability. Measure problems. These phrases do not have the cinematic force of a black hole, but to physics they signal something more serious than ordinary destruction. They signal that the rules may be incomplete, unstable, or pulling against one another. A supernova is violent but permissible. A theory that cannot consistently describe what happens to information is more alarming. A black hole merger is extreme but allowable. A framework in which singularities end predictability is more alarming. A lonely future is sad. A future in which the observational basis of cosmology itself is progressively erased is more alarming in a deeper sense. This is the great inversion. The deepest danger is not always what destroys matter. It is what threatens lawful intelligibility. Consider what it means for a moment for reality to keep books. That phrase sounds poetic, but it names something central. Our best theories are full of conservation laws, symmetries, correlations, and state descriptions. Physics works because the universe appears not to improvise arbitrarily. The future is constrained by the past in rigorous ways. Information about systems evolves. Degrees of freedom transform. Even when dynamics are chaotic, they are chaotic inside a lawful structure. That is the background trust. Now imagine the structure failing. Imagine a process in which a fully specified physical state evolves into outcomes that cannot be reconciled with unitary quantum evolution. Imagine a region where predictability ends not because we lack data, but because the theory itself stops providing a lawful continuation. Imagine a vacuum not as a final foundation but as a provisional plateau. Imagine a universe whose future slices reality into ever more disconnected islands. Imagine a far future where free energy gradients run out, leaving law intact but structure progressively starved. These are not merely sad or dramatic possibilities. They are humiliations to the old intuition that reality is a stable stage. And that is why physicists speak the way they do when certain problems arise. A good theorist may sound calmer than the public while discussing black holes, because black holes, however extreme, still sit inside equations. But introduce a genuine inconsistency, a paradox that threatens the coherence of two great frameworks at once, and suddenly the tone changes. Because a paradox is not just confusion. It is often a flare fired by reality itself. It says, "You have reached the edge of your present language." That is exactly what happened with black hole information. It is what singularities do classically. It is what the vacuum energy problem does to naturalness intuitions. It is what quantum gravity as a whole does to the marriage between smooth spacetime and quantum mechanics. Physics, then, does not fear destruction in the first instance. It fears the failure of lawful continuity. This is one reason black holes are already more frightening to professionals than to the public. The public sees a devouring object. The physicist sees a local region that forces thermodynamics, relativity, and quantum theory into the same room and watches them begin to argue about first principles. And once physics has learned to fear inconsistency, several candidates emerge for what may be worse than black holes. Not because they are more dramatic. Because they threaten deeper layers of order. The information paradox threatens the integrity of quantum evolution. Singularities threaten predictability. Cosmic horizons threaten permanent accessibility. Entropy threatens the long-term sustainability of organized complexity. Vacuum instability threatens the apparent foundation of ordinary law. Accelerated expansion threatens a shared cosmic future. None of those has the clean silhouette of a black hole. But each one attacks something black holes merely dramatize. That is the pattern we are following. The visible danger prepares us for the invisible one. A black hole is terrible because it creates a one-way region in spacetime. But what if the deeper danger is not one object with a one-way boundary? What if it is the possibility that information itself is not safe in the way we thought? What if it is the possibility that the vacuum beneath every atom is conditional? What if it is the certainty that the future accessible universe contracts in a meaningful sense? What if the real terror is not collapse in one place, but the gradual or sudden failure of the universe to remain narratable at all? To see the first of those clearly, we need to talk about the most famous accounting crisis in modern physics. The black hole information paradox. Because it is here that fear moves decisively from what happens to matter to what happens to law. There is a sentence at the heart of modern physics that sounds modest until you understand what it commits us to. The universe appears to evolve lawfully. That does not mean everything is predictable in practice. Chaos exists. Complexity exists. Measurements are limited. But underneath that mess, our deepest theories strongly suggest that evolution is not arbitrary. States transform according to structured rules. Information may become dispersed, scrambled, inaccessible in practice, but fundamental law does not casually forget. That faith is especially sharp in quantum mechanics. Closed quantum evolution is unitary. Information is not supposed to be fundamentally erased. A pure quantum state should not simply become a truly mixed state by magic. Correlations matter. Histories matter. The universe seems to keep accounts. Then black holes arrived and challenged that trust. Imagine forming a black hole from a complicated quantum state. Matter, radiation, correlations. Everything that specifies the initial state falls inward. From the outside, according to classical no-air simplicity, the final black hole is described by only a few macroscopic parameters: mass, charge, angular momentum. Enormous descriptive detail seems to disappear behind the horizon. That alone is unsettling, but not yet fatal. Hidden is not the same as lost. Then came Hawking's semi-classical result: black holes radiate thermally. Over unimaginable timescales, they can evaporate. And this is where the problem becomes severe. If the outgoing radiation is purely thermal in the relevant information-carrying sense, and if the black hole evaporates away entirely, then what happened to the detailed quantum information about everything that formed it? If it is truly gone, then quantum theory's ordinary rules are violated. If it is somehow preserved, then where and how is it encoded? In subtle correlations in the radiation? On the horizon? In some non-local feature of quantum gravity? This is not a technical quibble. It is a crisis over whether reality keeps coherent books. The paradox matters because it pits two immensely successful frameworks against one another. General relativity seems to permit black holes with horizons and classical interior regions. Quantum theory seems to demand unitary evolution. Hawking's semi-classical treatment appears to threaten that unitary demand. All three cannot be combined naively without tension. And the tension is not about a remote astrophysical oddity. It is about whether the universe can lose track of itself. That is why the information paradox belongs in a documentary about things worse than black holes. A black hole can destroy a star. A genuine breakdown of unitarity would threaten the logic by which physical histories remain coherent. Now, there has been real progress. This is important. We must not freeze the story in its most melodramatic form. Over decades, many ideas have reshaped the conversation. Black hole complementarity suggested that different observers may have different valid descriptions without any one observer witnessing contradiction. The holographic principle hinted that the information content of a volume may be encoded on a boundary. String theory and especially ADS/CFT provided strong evidence in certain settings that gravitational systems with black holes are dual to manifestly unitary quantum theories. More recently, work involving quantum extremal surfaces, islands, and replica wormholes has shown how semi-classical gravity, handled more subtly, can reproduce page curve behavior expected from unitary evaporation. These are not small developments. They suggest powerfully that the universe may preserve information after all. But notice what that means. Even if the paradox is resolved in favor of unitarity, the road to that resolution has already changed. The ontology of reality. It has told us that spacetime, entropy, information, and observer access may be interwoven far more deeply than common sense imagined. It has taught us that a black hole is not merely an object with strong gravity. It is a site where geometry, thermodynamics, and quantum information become inseparable. That alone is enough to shift fear upward from objects to structure. Because what terrified physicists was never simply falling in. It was the possibility that the universe's accounting system might be inconsistent. And if black holes only serve to reveal a deeper informational architecture, then the real horror was never the visible darkness. It was the fact that the darkness forced us to ask whether the world preserves coherent evolution in the first place. There is also an eerie psychological lesson here. People often assume that if information is preserved, the terror dissolves. It does not. Preserved is not the same as recoverable. Encoded is not the same as practically retrievable. Unitarity is not comfort. A diary thrown into a furnace may, in some absurdly distributed microscopic sense, still obey lawful evolution. That does not mean the original diary remains available to anyone. In black hole physics, the distinction between fundamental preservation and meaningful recoverability becomes profound. The universe may keep books in principle while making the books unreadable in practice for almost any observer that matters. That is already a colder model of reality. Lawfulness without mercy. Consistency without convenience. Information preserved in ways that may demand radically new ideas about space, interior, exterior, and access. So the information paradox does two things at once. It offers the hope that law remains consistent. And it reveals that if law remains consistent, it may do so through structures stranger than ordinary. Spacetime intuition can comfortably hold. Either way, black holes stop being endpoints. They become gateways to a universe where information, geometry, and observability are entangled. And once you start thinking in those terms, another problem sharpens. Not the question of whether the universe keeps accounts. The question of whether it always remains predictable. Because a theory can preserve information in principle and still hit regimes where it no longer provides a usable continuation. That is where singularities enter. Not as vague symbols of infinite density, but as technical injuries to predictability itself. The word singularity has suffered from popularity. It is used to mean very intense, world-changing, beyond normal, and in some circles almost any moment of technological upheaval. In serious gravitational physics, it means something colder and more specific. A singularity, very roughly, is not just an ultradense point. It is a sign that our classical description of spacetime reaches a limit where geodesic evolution cannot be extended in the ordinary way. Curvature invariants may diverge. Timelike or null paths may become incomplete. The theory, followed honestly, encounters a place where its own descriptive machinery runs out. That is not just dramatic. It is a scandal. Science depends on more than describing what happens under mild conditions. It depends on extending lawful relations from one moment to the next. If a theory says, "Push me far enough and I stop delivering predictive continuity," then the theory has found not merely a difficult region, but a boundary of its own competence. This is why singularities are worse than the public usually understands. The public hears infinite density and imagines crushing. The physicist hears breakdown of predictability. And the second is more severe. A universe can survive local destruction. A lawful framework cannot survive the end of coherent evolution without demanding replacement. Black holes give us one setting for this. Under classical general relativity, gravitational collapse. can produce singular behavior concealed within horizons. The early universe gives us another run. Classical cosmology backward, and the hot, dense initial state tends toward a singular limit, suggesting that our classical spacetime picture cannot be the full story at earliest times. Now, a crucial point of discipline: most physicists do not believe singularities, interpreted naively as literal completed physical infinities, are the final truth of nature. Rather, they are usually read as signs that general relativity is incomplete in those regimes and that quantum gravity must replace or modify the classical story. That is true, and it matters. But it does not make singularities comforting. It means the classical universe carries within it the seeds of its own descriptive collapse. It means our best current large-scale theory works magnificently and still drives us toward places where it can no longer speak fully. That is an architectural fear. The world is not just dangerous within theory. Theory itself comes with internal boundaries. And then there is cosmic censorship. This idea, broadly speaking, is the hope that nature hides singular pathologies behind event horizons, keeping them from contaminating the wider predictive structure of spacetime. If collapse produces singular regions, perhaps those regions are not naked to the rest of the universe. Perhaps the world protects its own intelligibility by veiling its ugliest failures. Notice how strange that is. We want the universe to be merciful enough to hide its breakdowns. That is what cosmic censorship means emotionally. It is the hope that the abyss remains behind a curtain. If that hope is right in the relevant physical sense, then singularity is terrible but quarantined. If it fails generically, if nature admits naked singularities under realistic conditions, then the threat becomes worse. Predictability would not merely fail deep inside hidden regions. It could fail in ways open to the larger world. This is one reason singularities belong in this documentary. They mark the difference between ordinary catastrophe and structural catastrophe. A supernova is catastrophic. A black hole can be catastrophic. A singularity is not merely catastrophic. It says, here the theory ceases to extend the chain from earlier to later in the way you trusted. And it is worth pausing on how severe that is for beings like us. We are creatures of continuation. We live by assuming that the future, however uncertain in detail, remains tied to the past by law. Memory, inference, and prediction all presuppose that the universe is not arbitrary from one moment to the next. Singularities, at least classically, show us a place where that presupposition reaches a formal edge. Even if quantum gravity ultimately heals the wound is real as a clue. It tells us that spacetime in its smooth classical form is not final. It tells us that extreme gravity is not just strong gravity. It tells us that what looks continuous can terminate in terms of current theory. It tells us that the world may preserve its deepest secrets precisely where ordinary explanation fails. So again, the motif returns. Black holes are visible terror. Singularities are hidden terror. And hidden terror is worse in a specific way: it does not merely destroy matter. It threatens the continuity of law. Yet even singularities, if hidden behind horizons, remain localized. The next fear general relativity and cosmology teach us is larger than that. It is the fear of permanent separation itself. Because horizons are not only black hole features. The universe has global horizons too. And those horizons do not just hide regions. They divide futures. The first mistake we make about horizons is thinking they are things. A wall is a thing. A shell is a thing. A membrane is a thing. A horizon is subtler. A horizon is a boundary in what can affect what. That is why it feels so eerie. It is not usually made of matter. It is made of causal structure. It marks the limit of communication, influence, or return. It is less like a barrier and more like a sentence written into the geometry of reality. Black holes give us the most famous horizon. Cross the event horizon of a black hole and the future-directed paths available to you no longer include escape to the external universe. The geometry has altered what later can mean. But once you understand that, a larger truth becomes visible. Horizons are not exclusive to black holes. Cosmology has horizons too. There is a particle horizon, the boundary of how far signals could have reached us since the beginning of the observable universe. There is a last scattering surface, beyond which ordinary electromagnetic observation does not simply proceed because the early universe was once opaque. Most hauntingly, in an accelerating universe there is a cosmic event horizon, a boundary beyond which events occurring now will never be able to influence us, no matter how long the future lasts. This is where fear becomes cosmological. A black hole horizon is local exile. A cosmic event horizon is large-scale exile. A distant galaxy beyond that horizon is not unreal. It does not cease to exist. Stars may still be forming there. Planets may still cool. Civilizations may rise, wonder, and vanish there. But their present and future can slip outside any possible causal relation to us. Their later history will never enter our future light cone. Their reality remains, but our share in it ends. That is a strange kind of death. Not the death of matter. The death of mutual future. Human beings are not used to fearing that because ordinary life trains us to think of existence as the primary category. But in physics, relation matters just as much. To say that something is part of your world in a physical sense is not only to say it exists. It is to say there is or could be causal exchange. Information can pass. Influence can occur. Histories can join. Horizons end that joining. And that is why horizons are more terrifying than they first appear. They are not just boundaries of sight. They are boundaries of participation. A black hole tells you there is a region you cannot get out of. Cosmological acceleration tells you there are regions of the universe that can continue magnificently and still never again become part of your future in any communicative sense. That is colder. Because it means the universe can lose commonality without losing existence. There is also a thermodynamic and informational depth here. Horizons are not just causal curiosities. Black hole horizons carry entropy and temperature. De Sitter-like horizons associated with accelerating spacetimes also bring thermodynamic ideas into play. This suggests that the limit of access is not incidental. It may be tied to the deepest microscopic structure of spacetime itself. In other words, the universe appears to count what can be hidden. That is a shocking thought. Access may itself be a physical quantity. Boundary may itself carry entropy. The line between observable and forever inaccessible is not just a human limitation. It may be part of reality's architecture. And once that idea is in place, black holes stop being unique teachers of terror. They become the local case of a broader principle. The world can partition itself into regions that remain real but cease to remain mutually available. That already sounds like a philosophical problem. In the far future, it becomes an existential one. Because cosmological horizons do not sit still in emotional significance. As the universe accelerates, more and more of reality becomes causally irrelevant to any one local island. Not destroyed. Not erased. Exiled from participation. And to us, that matters profoundly, because the value of the universe to creatures like us is not merely that it exists. It is that it can be known, shared, measured, responded to. A horizon does not need to eliminate a thing to make it vanish from meaningful future relation. That makes it one of the purest examples in physics of a danger that is worse than ordinary. Destruction. Destruction is brutal but clear. Permanent separation is quieter and, in a way, lonelier. And when you combine permanent separation with thermodynamics, the picture becomes even harsher. Because horizons divide futures, but entropy flattens them. That is where the long exhaustion begins. Heat death. Not a scream. A subtraction. If black holes terrify because they are concentrated, heat death terrifies because it is diffuse. It does not arrive like impact. It does not devour like a predator. It does not give you a single boundary to point at and say, there, that is where the danger begins. Heat death is what catastrophe looks like when the universe chooses patience over spectacle. To understand why it matters, we have to talk about thermodynamics in its most existential form. Everything interesting depends on gradients. Stars shine because fusion operates under structured conditions. Planets support weather because energy flows from hotter to colder reservoirs. Living systems persist because they feed on free energy and export entropy. Civilizations function because usable energy differences can be harnessed for work, computation, storage, and complexity. A perfectly equilibrated universe would not necessarily be nothing. It would be worse for beings like us. It would be a universe in which the structured imbalances that make work possible have thinned out so thoroughly that organized complexity becomes extraordinarily hard or impossible to sustain. That is the basic idea behind heat death. Not universal fire. Not some giant flame. The heat in heat death is historical language tied to thermodynamics, not a prediction that everything ends by becoming hot in the everyday sense. The far future of a universe like ours is more naturally imagined as cold, sparse, and diluted. What disappears is not temperature as such. What disappears is useful contrast. And useful contrast is everything. Without gradients, there is no sustained work. Without work, no metabolism in the broad physical sense. Without available free energy, no long-lived computation, no engines, no rich chemistry of organized structures on familiar scales, no flourishing archipelagos of complexity. This is why heat death belongs in a conversation about things worse than black holes. A black hole can kill locally. Heat death starves the universe of the very conditions that let interesting things happen at all. Stars do not shine forever. Star formation tapers off. Matter organizes, decays, cools, or becomes locked into remnants. Black holes themselves, if Hawking evaporation holds as expected, eventually radiate away over absurd timescales. The cosmic inventory grows poorer in free energy opportunities. Again, details depend on unknowns. Proton decay may or may not occur. Dark matter may have its own late-time story. Quantum gravity may add surprises. But the broad thermodynamic lesson is robust. The universe does not owe organized difference forever. And organized difference is what meaning-friendly physics requires. By meaning-friendly physics, I mean the sort of physical environment in which memory can persist, complexity can arise, structured systems can feed on gradients, and observers can exist as more than brief fluctuations. Heat death is terrifying because it is not a local failure of one object or one region. It is the exhaustion of the conditions that allow significance-bearing processes to continue in the rich way we know. This is not only about life in the biological sense. Even a machine civilization, a post-biological intelligence, a network of computation spread across Stars, any imaginable large-scale organized process would still depend on thermodynamic conditions. No philosophy escapes entropy. No technological optimism escapes the need for usable energy. That is why heat death is so deep a fear. It is not anti-human. It is anti-structure. The universe does not need to hate life to eventually stop making life easy. It does not need to attack civilization to make civilization unsustainable on cosmological timescales. It only needs to keep following thermodynamics. There is a cruel elegance to that. A black hole is easy to fear because it looks violent. Heat death should be feared because it is lawful. Not law-breaking. Law continuing. This is a recurring theme in the entire documentary. The deepest dangers are often not exceptions to physics. They are physics, followed patiently enough. And that patience does something psychologically interesting. It causes the imagination to fail. Human fear is tuned to events on legible timescales. Heat death unfolds over scales so vast that the ordinary emotional circuits struggle to engage. It feels remote, therefore abstract, therefore faint. But remoteness does not reduce depth. A structural exhaustion of the cosmos is not less serious because it lacks immediacy. It is more serious in some respects because it is not contingent on one spectacular accident. It is what the broad thermodynamic arc appears to favor. And heat death becomes even more severe when paired with cosmic acceleration. It is one thing for usable gradients to run down over time. It is another for regions of the universe to be causally severed from one another while that happens, turning the cosmos into isolated islands drifting through a thinning future. That is where dark energy enters. Not as an explosion. As quiet violence. A violence that does not rip by default, but separates, redshifts, and archives the universe away from itself. The discovery that the expansion of the universe is accelerating remains one of the most unsettling observational facts in modern cosmology. If the universe had merely expanded, that would already have been extraordinary. But acceleration means that the large-scale geometry of reality is evolving in a way that changes not only distance, but access. We call the driver dark energy, a phrase that names our ignorance as much as our knowledge. It may be a cosmological constant, a vacuum energy associated with space itself. It may be some more dynamical component. It may reflect a deeper modification of gravity in ways not yet resolved. But whatever its ultimate explanation, the observed effect is real enough to matter profoundly. Because acceleration changes the fate of relation. In an accelerating universe, sufficiently distant galaxies recede in such a way that light they emit now will never reach us. Their older light may still arrive for a while. We may continue to see them as they were. But more and more of their future becomes permanently disconnected from ours. This is not ordinary distance. It is causal exile written into cosmic expansion. And this is where dark energy begins to feel worse than a black hole in a very particular philosophical sense. A black hole is local. You can identify it. You can map its influence. It is a region of danger in a broader connected universe. Dark energy affects the background stage itself. It does not need to destroy a galaxy to remove it from your future. It only needs to stretch spacetime such that the galaxy's later history can never again cross into your causal domain. That is an astonishing kind of violence. Not violence by collision. Violence by disconnection. The universe remains populated. The stars still shine elsewhere. Histories continue. But the common world fractures. This is one of the great emotional understatements of cosmology. We often speak of accelerating expansion as if it were merely a change in the graph of scale factor versus time. Mathematically, yes. Existentially, it is the progressive severing of relation across the largest scales. That changes how we should think about the future. The far future universe may not be simply old. It may be lonely in a principled way. Future observers bound within what remains of our local group may see an increasingly empty sky. Extragalactic evidence could fade. The Hubble expansion may no longer be readily inferable. The cosmic microwave background may redshift into practical invisibility. Clues to the larger story of the universe may be lost not because they were false, but because the geometry of the cosmos withdraws them from reach. This is an epistemic catastrophe as much as a physical one. It means the universe can become less knowable with time. That is hard to feel because we are trained by everyday life to treat knowledge as cumulative. The future knows more. The archive expands. But cosmology reveals a colder possibility. Observational privilege is historical. There may be eras in which the universe is unusually legible, and others in which it is not. We appear to live in one of the legible eras. That is astonishing and a little tragic. Because it means the universe is not just expanding. It is editing its own accessibility. Dark energy therefore belongs in this documentary because it is not merely a driver of scale. It is a driver of long-term separation, redshifted silence, and eventual evidentiary loss. It does not announce itself with horror movie drama. It does not attack. It simply changes the future such that large portions of reality no longer remain part of any shared causal story available to local observers like us. Black holes are visible terror. Dark energy is administrative terror. It is the quiet reclassification of most of the universe into, no longer relevant to your future. And then there is the more dramatic speculation, the Big Rip. If the effective equation of state were sufficiently extreme, accelerated expansion could eventually overcome not only large-scale structures but smaller bound systems, tearing apart galaxies, solar systems, planets, molecules. Perhaps even nuclei. Current evidence does not require this. It remains a model-dependent scenario, not the standard expectation. But notice what even the standard picture already teaches. You do not need the Big Rip to make acceleration terrifying. You only need a cosmic event, horizon, and enough time. Because relation itself becomes finite. And this prepares us for a threat even stranger than accelerated isolation. A threat with no warning. A threat that would not merely separate regions of the universe, but potentially change the vacuum beneath every field and particle we know. False vacuum decay. If heat death is the long exhaustion and dark energy is the quiet exile, false vacuum decay is something else entirely. Instant structural catastrophe. No spectacle. No siren. No approach. Only the possibility that the floor was never the floor. There are disasters you can see coming. A star nearing instability. A merger trajectory. A rising accretion flare. A tidal disruption event beginning to unfold. False vacuum decay offers no such decency. To understand why, we have to be very careful with the idea of vacuum. In ordinary language, a vacuum is empty space. Nothing. Blankness. In quantum field theory, a vacuum is not simple nothingness. It is the state of lowest accessible energy for the fields that pervade reality, or at least what appears to be the lowest accessible energy. Under the relevant conditions. Even empty space is structured, active in the quantum sense, full of field configurations and fluctuations. The vacuum is not the absence of physics. It is a physical state. Now suppose that the vacuum we inhabit is not the true absolute minimum of the relevant potential landscape, but a local minimum, a metastable state. Like a ball resting in a valley that is stable against small perturbations but not globally the deepest possible valley. If that is the case, a transition to a lower energy vacuum could, in principle, occur through quantum tunneling. And if such a transition occurred, it would not be like a conventional explosion. It would nucleate a bubble of new vacuum state. That bubble would expand. In idealized treatment, the bubble wall moves outward at or near light speed. Crucially, no warning signal can outrun the wall to announce it. You do not see it coming. You cannot. That alone gives false vacuum decay a special place in the hierarchy of fear. But the real severity lies deeper. A transition to a different vacuum is not just a change of scenery. It can alter the effective parameters that define ordinary physics: particle masses, coupling strengths, symmetry breaking patterns, the stability of atoms, the existence of chemistry as we know it. The structures built under one vacuum may be impossible under another. This is why false vacuum decay is not just a big explosion. It is a revision to the local rules. A black hole destroys within law. False vacuum decay would potentially replace the locally realized law beneath matter itself. That is more severe in category. Now, discipline again, is this established as our fate? No. The possibility arises from how the standard model behaves when extrapolated to very high energies, especially given measured values for quantities like the Higgs mass and top quark mass. Some analyses suggest that the electroweak vacuum may be metastable rather than absolutely stable, though with a lifetime enormously longer than the current age of the universe. But these calculations depend on extrapolations far beyond current direct tests, and new physics could alter the conclusion dramatically. No responsible scientist says the end is scheduled. But responsible uncertainty is enough. Because even as a serious possibility, false vacuum decay reveals something about reality that is hard to unlearn. The apparent foundation of ordinary existence may be conditional. A very long-lived condition is not the same as an ultimate guarantee. That insight radiates far beyond vacuum decay itself. It becomes a cosmological mood. Stars are long-lived, not eternal. Planetary climates are stable, until they are not. Galaxies endure, but evolve. Horizons limit relation. Entropy drains opportunity. And perhaps even the vacuum is a prolonged truce rather than a final peace. That is a chilling way to understand the world. Because it means reality's reliability may be layered. Stable enough for billions of years. Stable enough to generate elements, planets, life, civilizations, thought. Yet not necessarily final in the deepest sense. And there is a particularly cruel elegance in the false vacuum scenario. It does not destroy by impact. It destroys by replacement. Not by striking matter harder than matter can withstand. By making the old form of matter no longer viable. It is the purest example in this documentary of an invisible revision. No visible monster. No dark mouth in the sky. No gravitating local enemy. Only the possibility that the stage beneath existence has a lower level and that a transition, if it occurs, would erase the relevance of all ordinary survival instincts. In human terms, it is almost too severe to fear properly. There is no fleeing it. No observing it from afar. No preparing psychologically for the exact moment. There is only the recognition that the quiet background of physical law, the thing we call nothing, may carry deeper contingency than common sense allows. That is why false vacuum decay occupies such a special place in the hierarchy of structural terror. It combines invisibility, fundamentality, and the annihilation of warning. But its importance is not just as a doom scenario. It matters as a philosophical lesson. The lesson is that stability is not the same as finality. The universe may not need to hide a larger beast than black holes. It may only need to be less anchored than we assumed. And once that idea takes hold, you begin to see why invisible threats can be psychologically worse than visible ones. Because at least visible monsters acknowledge the world they threaten. Invisible structural threats threaten the world as world. A visible danger has manners. It lets you know what category it belongs to. A wolf is a predator. A storm is weather. A cliff is a boundary. A black hole is an abyss. Once the mind identifies the category, it mobilizes. Fear becomes directional. You can imagine fleeing, fighting, mapping, or at least respecting the threat. Even when survival is impossible, the emotional system still feels oriented. Invisible threats are different. They do not give the nervous system a shape to grip. They refuse symbolism. They remain conceptually severe while being visually poor. And because humans are image-hungry creatures, this can make them psychologically worse once understood. A black hole is terrifying, but it still flatters the old architecture of fear. It says, there is the danger. That dark place. That one-way region. That wound in the sky. Heat death says something else. The danger is a thermodynamic destiny, a broad exhaustion of usable gradients. Dark energy says, the danger is that the future becomes less shared. Vacuum instability says, the danger may be hidden in the apparent emptiness beneath all fields. The information paradox says, the danger is that the rules by which the universe retains coherent accounts may be subtler or more fragile than you thought. Singularity says, the danger is the collapse of lawful continuation under present theory. These do not behave like enemies. They behave like conditions. And conditions are harder to metabolize. The human mind prefers antagonists to frameworks. We prefer a monster to a law, because a monster still leaves the law intact. We can imagine beating the monster, escaping the monster, or at least admiring its localness. But a law or condition cannot be fought in the old way. It must be understood, endured, or placed in relation to larger patterns. That is a more difficult emotional task. This is why many people instinctively fear black holes more than entropy. One offers a picture. The other offers a sentence. Yet from the standpoint of long-term cosmic severity, the sentence may cut deeper than the picture. There is also a problem of scale. A visible danger is usually local. A black hole threatens a region. Even if that region is extraordinary, the wider world remains. An invisible structural threat often scales beyond locality. Entropy is universal. Accelerated expansion is cosmological. Vacuum structure is foundational. Predictability crises reach into the conceptual core of law. To put it simply, visible monsters threaten things inside the universe. Invisible structural threats threaten the universe as a setting for certain kinds of things. That is why they are psychologically abrasive. They do not just scare us. They strip orientation. If the danger is over there, we know where we stand. If the danger is built into the conditions of reality, we do not. And then there is the matter of timing. Visible threats often arrive with escalation. We see signs. We imagine approach. Invisible threats do not grant that. Heat death is too slow to notice directly. Dark energy isolation is too patient for instinct. Vacuum decay, if real and realized, would give no warning at all. Horizon loss occurs not as a shout, but as a gradual redefinition of what can ever matter to whom. This makes invisible threats feel unreal until they suddenly feel worse than unreal. They feel structural. That word again. Because structure is what the human mind quietly depends on while pretending it only depends on objects. We think we need food, shelter, and companionship. True. But underneath all of that we need a world in which the laws remain stable enough, the energy gradients remain rich enough, the vacuum remains permissive enough, and the horizon structure remains connected enough for food, shelter, and companionship to be possible at all. Invisible structural threats attack there. And that is why this documentary keeps returning to the same motif. Black holes are visible terror. The deeper horrors are invisible revisions. Not revisions to one region. Revisions to the terms of relation. Once you begin to think like that, the whole universe changes character. It stops looking like a permanent stage on which occasional dramatic objects appear. It begins to look like a conditional arrangement, a system of temporary permissions. That is our next step. Because behind entropy, behind horizons, behind vacuum anxiety, behind all of it, there is a broader cosmological mood. Metastability. Not only in the technical particle physics sense, but in the sense that much of what we rely on may be a long-lived arrangement rather than an absolute guarantee. Human time is too short to understand permanence intuitively. Whatever lasts longer than our civilizations begins to feel fundamental. Mountains feel permanent. Oceans feel permanent. Orbits feel permanent. The star overhead feels permanent. Ordinary matter feels final. The background conditions of the universe feel like a stage that was there before us and will remain after us in roughly the same conceptual form. Modern physics keeps taking that comfort apart. Stars are long-lived, not permanent. Galaxies endure, but transform. Planetary conditions are contingent. Horizons shift what remains accessible. Energy gradients run down. Even the vacuum may be only metastable. This is why metastability is not merely a technical word. It is a cosmological mood. A metastable system is stable enough to persist, often for enormous timescales, yet not in the deepest available state. It can sustain structure, perhaps brilliantly, while still carrying the possibility of transition. Reality seems full of such long truces. Atoms are stable under ordinary conditions. Stars are stable for immense durations. Chemical complexity is stable within certain cosmic epochs. Cosmological structures persist over billions of years. This abundance of stability tempts us to mistake endurance for ultimacy. But endurance is not ultimacy. A thing can last longer than our species and still be temporary in the larger grammar of the universe. This matters because almost everything we care about depends not on eternity, but on a network of conditional permissions. The constants of nature must sit within viable ranges. Symmetry must break in ways that allow particle masses and chemistry. Stars must manufacture heavy elements. Planets must capture and sustain useful gradients. Quantum states must evolve lawfully. Spacetime must remain sufficiently regular. Free energy must remain available. Complexity is not the default. It is a negotiated pattern. That is the deeper lesson behind metastable order. The universe did not merely place objects into empty space. It permitted long intervals during which structure, memory, and organization could arise. Those intervals feel absolute only because we are born inside them. Once you see that, fear changes character. You stop asking only, what if something destroys us? You start asking, what if the permissions themselves are temporary? What if the universe is less like a solid building and more like a long-lived waveform? Stable enough to live inside, but not necessarily final at the level our instincts prefer. What if existence is layered with thresholds beneath thresholds, stability resting atop deeper stability, never quite reaching an intuitively satisfying floor? This is not nihilism. In some ways, it makes reality richer. It means structure is an achievement, not a default. But it also makes reality more severe. Because it means the things we value are not secured by metaphysical comfort. They are secured by conditions. And conditions can erode, shift, or prove incomplete. This is why black holes may not be the worst thing. A black hole is a particular object born within the arrangement. Metastable order asks whether the arrangement itself is provisional. And that thought binds together much of this documentary. Heat death says the arrangement can thermodynamically thin out. Dark energy says it can lose shared accessibility. Vacuum instability says the ground beneath it may not be final. Information paradoxes say its bookkeeping may demand deeper rules than familiar spacetime offers. Singularities say our current descriptive authority can fail under extremity. All of this suggests that the universe is not simply there. It is maintained, at every scale, by relationships, balances, symmetries, asymmetries, and energetic structures that need not have lasted, and need not last forever. That realization can feel terrifying because it removes the fantasy of static reality. But it can also sharpen meaning. A stable thing is not less valuable because it is conditional. It may be more valuable because it depends on a rare corridor of permissions. Still, sharp meaning is not the same as comfort. The universe as metastable order is not cozy. It is majestic, exacting, and in places deeply unforgiving. And nowhere is that more emotionally visible than in the future of observability. Because metastability is not just about matter and vacuum. It is about whether the universe remains readable. The future may not only be colder. It may be more silent. And that silence is not metaphorical. It is built into the horizon structure of an accelerating cosmos. There is a tragedy built into cosmology that rarely receives the emotional attention it deserves. The universe is not only vast. It is perishable as evidence. Right now we can still see distant galaxies. We can still detect the cosmic microwave background. We can still reconstruct the expansion history of the universe. We can still read ancient light and infer a story that stretches back almost to the beginning of transparent cosmic time. That accessibility feels natural because it is the only era we know. But it is not natural in the deep sense. It is historical. We live in a period when the universe is unusually legible. That may not last. In an accelerating universe, more and more distant regions slip beyond practical or ultimate causal significance. Their light grows increasingly redshifted. Their observable evolution slows. Their later histories cease to matter to us in the strict sense that they can no longer send new information into our future. The cosmic microwave background, once a brilliant clue to the early universe, stretches to wavelengths so vast and faint that future observers may be unable to detect it meaningfully. This means that cosmology, as we practice it, may be an era-bound privilege. Future civilizations, if they exist trillions of years from now inside a bound local remnant galaxy, may inherit a much poorer sky. They may see few or no external galaxies. They may lack clear evidence for the Hubble expansion. They may be cut off from the observational archive we use to infer the Big Bang and large-scale structure. Imagine that. A civilization brilliant in local physics, precise in mechanics, chemistry, maybe even quantum theory, and yet living in a sky whose larger story has been withdrawn. Their theories about the total universe might be radically constrained, not because they are less intelligent than us, but because reality has archived the evidence away. That is chilling. Because it means the universe not only allows knowledge, it times it. Knowledge becomes another conditional corridor. This is why shrinking observability belongs among the deeper horrors. It is not simply about not being able to see far. It is about the gradual collapse of common cosmic evidence. It is about the universe becoming, for local observers, less richly self-disclosing. Black holes hide their interiors. Cosmic acceleration can hide the wider universe's later history. Both are forms of withholding. But the second is perhaps harsher, because it acts not on one local region, but on the future relation between islands of reality. There is a spiritual abrasion here too. We tend to imagine science as an ever-expanding conquest of ignorance. Cosmology says, sometimes the archive itself degrades. Sometimes being later means inheriting less. Sometimes there is a best hour to ask certain questions, and after that hour the evidence fades. We may live inside such an hour. That is both a privilege and a warning. A privilege because the universe still lets us see far enough to reconstruct a remarkable story. A warning because nothing says that generosity is permanent. The sky is not a permanent library. It is a shrinking window. And once you understand that, black holes begin to look less like the supreme darkness and more like one member of a broader family of cosmic withholding. The universe can limit access locally, through event horizons, and globally, through accelerated expansion. It can preserve reality while reducing relation. It can allow histories to continue while preventing those histories from ever entering one another again. That is not a spectacular apocalypse. It is something worse for beings who care about knowledge. It is the reduction of the shared knowable world. In a deep sense, that means the universe may not kill explanation all at once. It may simply narrow the domain in which explanation remains possible. And that leads us into the frontier scenarios. Physicists discuss cautiously, where several different kinds of nightmare sit side by side, some more plausible, some more speculative, all revealing how reality can threaten not just matter, but coherence itself. This is where honesty matters most. Frontier physics attracts two equal and opposite failures. One is sensationalism, treating every open problem as if it were tomorrow's apocalypse. The other is false calm, pretending that because something is uncertain, it carries no existential significance. Both are mistakes. So let us proceed carefully. What follows is not a catalogue of confirmed futures. It is a map of serious anxieties, model-dependent possibilities, and conceptual warnings that appear when modern physics is pushed hard enough. The Big Rip. One speculative but famous possibility is the Big Rip. In some models where the effective dark energy equation of state falls below the cosmological constant value in a sufficiently extreme way, the expansion of the universe accelerates so violently that bound systems can eventually be torn apart. First galaxy clusters, then galaxies, then solar systems, then planets, then molecules, perhaps. Finally, even atomic structures. This is dramatic, yes, but current observations do not require it. The standard cosmological model does not point cleanly to this outcome. It remains a frontier scenario, important mostly because it demonstrates a principle: cosmic doom need not come from an incoming object. It can come from the behavior of the background expansion itself. Vacuum instability. We have already explored false vacuum decay, but as a frontier nightmare it deserves repeated emphasis because it is the purest example of structural catastrophe. Not a collapse of matter inside existing laws, but a transition in the vacuum beneath those laws. It is the difference between a house fire and a shift in chemistry such that houses no longer exist as a category. Boltzmann brains. This one sounds absurd until you understand its role. In certain cosmological scenarios involving eternal expansion, extremely rare fluctuations over stupendous timescales could produce isolated, observer-like systems, brief conscious structures with disordered or false memories, more often than ordinary observers generated by cosmic evolution. If a cosmological model predicts that typical observers should be such random fluctuations, then the model undermines its own connection to our orderly observed world. That is why this problem matters. Not because physicists expect disembodied brains to literally become the next phase of life, but because the issue touches the measure problem, typicality, and whether cosmology can remain epistemically coherent. It is not a monster. It is an attack on the credibility of explanation. Naked singularities and cosmic censorship failure. If cosmic censorship fails generically, singular behavior might not always remain hidden behind horizons. That would mean breakdowns in predictability could be exposed to the wider universe, rather than quarantined. Again, this is not established as the typical state of nature. But the reason physicists care is obvious: a publicly accessible pathology is worse than a hidden one. Chronology violation and causal pathology. General relativity admits exotic solutions featuring closed time-like curves and other strange causal structures. Most physicists suspect realistic quantum effects, chronology protection, or deeper principles prevent ordinary macroscopic time travel paradoxes. But the existence of such solutions in the mathematical landscape reminds us that consistency is not guaranteed merely because a differential equation permits a geometry. Nature may need extra rules to protect itself from pathological causal loops. Quantum gravity uncertainty. At the deepest level, we still do not know what spacetime fundamentally is. Smooth geometry may be emergent. Locality may be approximate. Interior and exterior descriptions may not mesh the way common sense expects. Entanglement may participate in the construction of spatial connectivity. The Planck scale remains a regime where our ordinary categories strain. This is not a single nightmare scenario. It is a background warning: the world may be stranger in substance than in any one catastrophe. What unites all these frontier cases is not that they are equally probable. They are not. What unites them is that they reveal how many different ways reality can be severe without behaving like a simple predator. Some threaten structure. Some threaten typicality. Some threaten causal order. Some threaten interpretability. Some threaten the assumption that our categories are final. And that is why they belong here. The title of this documentary is not really about hunting for one ultimate horror. It is about discovering that the deeper one goes, the more the hierarchy of fear shifts from objects to principles. Black holes remain extraordinary. But frontier physics keeps telling us the same story in different languages. The gravest risks may not be local beasts. They may be failures of coherence, access, stability, or lawful framing. Still, we need one more pause. Because at this point, fear can begin to run ahead of evidence. And that would be dishonest. So now we need a firm accounting. What do we know? What do we seriously worry about? And what belongs to disciplined speculation rather than established fact? Let us separate the layers clearly. What is established? Black holes exist. That is not a speculative statement. Stellar collapse, X-ray binaries, galactic nuclei, gravitational wave detections, and horizon-scale imaging all support the reality of black holes in the broad astrophysical sense. General relativity describes horizons as serious causal structures. Whatever quantum gravity ultimately adds, horizons are not fiction. The universe is expanding. That expansion is accelerating. Entropy governs the direction of thermodynamic change. The future thermodynamic impoverishment of the universe is a serious large-scale expectation. Under broad assumptions, quantum mechanics treats information evolution as centrally important. Singularities in classical relativity signal the breakdown of the classical theory in certain regimes. These are sturdy parts of the landscape. What is seriously studied and plausibly deep, but not settled? The exact resolution of the black hole information paradox. We have strong reasons to believe that fundamental unitarity survives, and major progress supports this, but the full story still teaches us that spacetime, entropy, and information are woven together more strangely than once thought. The absolute versus metastable status of the electroweak vacuum, given measured parameters and possible new physics. The question is real, even if the answer remains uncertain. The ultimate long-term implications of dark energy. The standard picture of continued acceleration is robust enough to imply future isolation, but the underlying nature of dark energy remains unresolved. The detailed resolution of singularities by a future quantum gravity theory. We expect the classical breakdown to be healed somehow, but somehow still matters. What remains speculative or model sensitive? A guaranteed big rip. An actual false vacuum transition in our future. Boltzmann brane dominance as a correct guide to cosmic typicality. Generic naked singularities in nature. Any single final ontology for spacetime, holography, emergence, or quantum gravity that can be declared settled today. Why insist on this classification? Because disciplined fear is stronger than lazy fear. Lazy fear flattens everything into apocalypse. Disciplined fear respects evidence and still discovers that reality is severe enough. It does not need inflation. And the disciplined picture is already haunting. It tells us black holes are real and conceptually powerful. It tells us horizons matter. It tells us entropy is not negotiable. It tells us acceleration is redrawing the long-term map of accessible relation. It tells us our understanding of information and gravity is incomplete in foundational ways. It tells us the vacuum may not be as obviously final as common sense assumes. It tells us the universe can become less knowable, not just older. That is enough. Enough to say with seriousness that black holes may not be the deepest danger. Enough to say that the visible abyss may only be the photogenic version of a more profound class of threat. Enough to say that the universe does not need a larger beast than a black hole in order to become more frightening than black holes already are. It only needs to contain deeper ways for coherence to fail. That is the important distinction. A larger beast would still be a beast. It would still be an object. It would still obey the grammar of ordinary fear. A deeper failure belongs to a different category. It belongs to the category of worlds that do not remain sufficiently stable, sufficiently connected, sufficiently lawful, or sufficiently interpretable to support the kinds of structures from which observers, explanations, and shared futures are built. This is why disciplined fear matters. Disciplined fear does not invent monsters. It notices what the equations, observations, and conceptual crises are already saying. They are saying that modern physics has repeatedly shifted the site of danger. From object to law. From violence to condition. From local catastrophe to structural attrition. From destruction to withdrawal. And once danger shifts in that way, the human mind has to shift with it. Because if we keep fearing only what can be pictured, we will misunderstand what reality has actually revealed. That brings us to the final two layers of the story. The first is psychological. What happens to a mind like ours when it realizes the deepest threats in the cosmos are not predators but conditions? And the second is philosophical. If black holes are not the darkest thing in the universe, what exactly have we learned about reality itself? Those questions are not separate. They are the human and cosmic halves of the same discovery. The human nervous system was not designed for cosmology. That is not an insult. It is a fact about scale. We evolved inside a narrow band of reality, middle distances, moderate speeds, local dangers. Visible causes, finite horizons measured in steps or seasons rather than gigayears. Our intuitions were trained on cliffs, storms, fire, predators, disease, hunger, isolation, and grief. The world our ancestors needed to survive was a world where danger usually had a location, a cue, and a response window. Cosmological danger behaves differently. A black hole already strains the old system, but it still gives us some of what the nervous system wants. It has a place. It has a boundary. It has a direction. It offers a dramatic image of no return. Even if we do not understand the mathematics, we understand the shape of the warning. That is why black holes dominate the imagination so effectively. They translate advanced physics back into ancestral fear. But the other dangers in this documentary do not. Heat death has no silhouette. Dark energy has no roar. A shrinking observable universe offers no visible teeth. The information paradox does not scratch at the window. Vacuum metastability does not pace in the distance waiting to be seen. A singularity hidden by cosmic censorship does not announce its conceptual violence in a way the body can feel. And so something strange happens. The deeper the threat becomes in physics, the less naturally the nervous system knows how to fear it. That mismatch creates a profound psychological distortion. We overfear what we can picture. We underfear what we cannot. We dramatize visible monsters and normalize structural fragility. We treat an asteroid like a nightmare and a thermodynamic future like an abstraction, even though the second may be a more universal and more total statement about what the universe eventually does to organized complexity. This is not irrationality in a moral sense. It is inheritance. The mind is built to care about immediate relevance. A cosmic horizon that slowly removes distant galaxies from future contact does not register as a tiger would. A law-level inconsistency between quantum theory and gravity does not make the pulse spike. A possible metastability in the vacuum under all matter does not cause the body to prepare for flight. Yet each of those threatens something more comprehensive than any tiger ever could. They threaten not a body in a place. They threaten the stage conditions under which bodies, places, memory, and meaningful futures exist at all. That is an extraordinary burden to place on intuition. Because our deepest emotional categories assume a stable world with occasional interruptions. Fear assumes a background. Grief assumes a continuity around the loss. Hope assumes a future structurally similar enough to the present that aspiration makes sense. Modern cosmology complicates all three. It tells us the background is not eternal. The continuity is conditional. The future is not merely later, it may be less connected, less observable, less energetic, less generous to structure than the present. This can sound like nihilism if handled badly. It is not nihilism. It is scale shock. Nihilism says nothing matters. Scale shock says the conditions under which things matter are stranger, rarer, and more contingent than we thought. That is a different claim. And it is, in a serious way, more beautiful. Because if meaning survives in a universe like this, then meaning is not an entitlement built into the walls of existence. It is an achievement of structure. It appears wherever lawfulness, memory, energy gradients, relation, and attention are able to coexist long enough for worlds of significance to form. In other words, meaning is not refuted by structural catastrophe. It is sharpened by it. A universe with guaranteed permanence would make significance cheap. A universe where every archive lasts forever, every relation remains open forever, every horizon is conquerable, every gradient inexhaustible, and every law transparently complete would be a very different kind of place. We might find it comforting. We might also take it for granted in a way that drains seriousness from existence. Instead, we inhabit something harsher. A cosmos where free energy matters because it runs down. A cosmos where relation matters because horizons can sever it. A cosmos where explanation matters because evidence can disappear from future access. A cosmos where law matters because some of our best theories still fracture at the edges. A cosmos where ordinary matter matters because even its vacuum background may be more conditional than common sense once imagined. This is difficult news for a mind shaped by permanence fantasies. But it is not bad news for seriousness. In fact, one could argue that the psychological maturity physics asks of us is precisely the maturity of caring inside contingency. Not pretending the world is guaranteed. Not pretending the universe arranged itself around human narrative comfort. Not insisting that the deepest dangers must look like the monsters our ancestors already knew how to fear. Instead, learning to feel awe and responsibility in a reality that is structurally unstable in some respects, conceptually unfinished in others, and profoundly indifferent to whether our intuitions like its architecture. That is hard. It is hard because we are story-making animals, and stories like closure. We like beginnings that lead to middles and middles that lead to endings. We like villains. We like climaxes. We like scales small enough that agency can imagine itself mattering clearly. Cosmological structure often denies us that form. Heat death is not a climax. It is attrition. Dark energy is not a villain. It is a background term in the equations whose meaning remains partially mysterious and whose consequences are civilization ally and cosmologically severe. Vacuum decay, if possible, is not a war. It is a phase transition. The information paradox is not a battle. It is a warning that our deepest descriptions are not yet reconciled. This is why cosmic horror, in the most mature scientific sense, is not really about fear of monsters. It is about fear of dislocation. Dislocation from intuitive scale. Dislocation from stable categories. Dislocation from the fantasy that reality is fundamentally object-centered and human-comprehensible in the way furniture and weather are. The universe modern physics reveals is not less lawful than we hoped. In many ways it is more lawful. But it is lawful in ways that can feel emotionally hostile because they refuse to flatter intuition. Entropy is lawful. Horizons are lawful. Accelerating expansion is lawful. Quantum unitarity, if preserved, is lawful. The apparent need for quantum gravity is lawful. What wounds us is not chaos in the everyday sense. It is the discovery that law itself may imply futures, limits, and conditions that the human nervous system would never have chosen. That is the psychological shock at the core of this documentary. Black holes let us keep one old comfort: danger still has a face. The deeper universe removes even that. It says the gravest threats are not always what charges at you. Sometimes they are what quietly constrains the space of possible worlds. Sometimes they are what slowly edits away the conditions required for complexity. Sometimes they are what reveals that the floor beneath existence is less final than it looked. Sometimes they are what shows that the universe can remain perfectly indifferent while becoming progressively less available to shared meaning. So what does a sane mind do with that? Not panic. Not retreat into fantasy. Not flatten every frontier concept into apocalypse content. What it does, if it can, is become more exact. More exact about fear. More exact about wonder. More exact about what it means to inhabit a lawful but not necessarily hospitable cosmos. This is where dignity enters. Not the dignity of conquest. No civilization is going to conquer entropy in the global thermodynamic sense. No species is going to repeal cosmic acceleration by force of optimism. No amount of human preference will retroactively make the vacuum obviously final or singularities classically healthy or the information paradox trivial. A different dignity is required. The dignity of lucidity. To know the universe may not remain meaning-friendly forever and still produce meaning. To know the accessible world is finite and still investigate it. To know evidence itself is historically perishable and still build cosmology while the archive remains open. To know the deepest threats are structural and still refuse theatrical dishonesty. That is not a small achievement. It may be one of the highest things intelligence can do. And it leads directly to the final synthesis. Because once we understand what the mind is up against, we can say more clearly what this documentary has actually shown. Not that there is one hidden object worse than black holes. But that black holes may have distracted us from a darker truth. The deepest risks in the universe may be built into the rules that make a universe possible in the first place. Let us gather the whole argument slowly, because this is the kind of subject that becomes less frightening when rushed and more frightening when stated with precision. Black holes are terrifying. That has never been in doubt. They bend spacetime into forms that common sense cannot naturally picture. They create horizons across which outward return no longer belongs to the future. They concentrate mass energy into systems so extreme that our best classical theory points toward singular behavior. They radiate thermodynamic meaning outward into fields like entropy, temperature, and information in ways that permanently altered modern physics. They are astrophysical facts and conceptual wounds at the same time. If the universe were trying to hand the imagination a symbol of danger, black holes would be close to perfect. And that, precisely, is the trap. Because black holes are frightening in the old way. They give dread a form. They localize it. They let fear point. What physics has slowly discovered is that the deeper dangers often do not permit pointing. They are not bigger mouths in the dark. They are not cosmic predators with worse appetites. They are not singular objects waiting beyond the next telescope image. They are conditions. Relations. Limits. Failures. Possibilities written into the structure of law. This is the central inversion of the entire documentary. The worst thing in the universe may not be what destroys the most matter. It may be what most deeply threatens the continuity, recoverability, intelligibility, and sharedness of reality. That is why the information paradox matters so much. Not because a paradox is flashy, but because it suggests the possibility of a bookkeeping crisis at the level of law. If information were not fundamentally preserved, then the universe would not merely be violent. It would be unfaithful to its own history in a deeper sense than physics is built to tolerate. That is why singularities matter so much. Not because infinite density sounds exciting, but because classical singularities signal that predictive description itself has encountered a limit. A universe where the chain from past to future becomes ill-defined is more disturbing than a universe with large explosions. Explosions occur within law. Predictive collapse threatens law's continuity. That is why horizons matter so much. Not because boundaries are inherently dramatic, but because a horizon is a limit of relation. It marks where mutual influence fails. A black hole does this locally. Cosmic acceleration does it globally. The danger is not simply distance. It is exile from shared future. That is why heat death matters so much. Not because it gives us a cinematic final battle, but because it names the long exhaustion of usable gradients. It is the slow impoverishment of the conditions under which work, memory, metabolism, computation, and organized surprise can occur. It does not merely kill worlds. It starves world-making. That is why dark energy matters so much. Not because its name is mysterious, but because its consequences reshape causality on the largest scales. The universe does not need to break violently to become lonelier. It can just keep accelerating until more and more of reality slides permanently beyond reciprocal access. That is why false vacuum decay matters so much. Not because we know it will happen, but because it reveals the stark possibility that what we take to be the floor of existence may only be a temporary resting point. The laws as presently realized may not be the last available arrangement. A black hole destroys within the stage vacuum decay. If it is physically possible in our world, would rewrite the stage. And that is why even the more speculative frontier nightmares deserve careful attention. Not because they are proven, but because they expose the categories modern physics worries about. When pushed hard enough, failure of coherence, failure of typicality, failure of chronology, failure of global interpretive stability, failure of our naive confidence that familiar concepts like locality, geometry, and vacuum are obviously fundamental in the forms we currently imagine. What unites all these fears is not that they are equally likely. They are not. What unites them is that they all shift danger away from objects and toward architecture. Away from local violence and toward structural threat. Away from dramatic death and toward the loss of the conditions that let complex life, memory, explanation, and common world exist at all. This is the real answer to the title. What may be hiding something far worse than black holes is not deep space in the sense of one hidden object lurking beyond our maps. It is the universe itself. Not because the universe is secretly malicious. Not because reality has a plan. Not because the cosmos is populated by intentional horrors waiting to reveal themselves. But because the rules of existence may already contain possibilities more severe than any single localized monster. The universe may not need a dragon bigger than a black hole. It may only need entropy, acceleration, metastability, conceptual incompleteness, and the lawful erosion of access. That is colder than mythology. Because mythology lets you fight. Structural reality does not care whether you approve of its terms. And still, there is something important to protect from misunderstanding here. This documentary is not an argument for despair. It is an argument for seriousness. The fact that the universe contains structural threats does not mean nothing matters. It means what matters does so under conditions that are not guaranteed forever. That is a harder truth, but not a smaller one. In fact, one could say that modern physics has done something spiritually disruptive and spiritually clarifying at the same time. It has taken away many of the old comforts. It has taken away the fantasy that the future must remain open in every direction. It has taken away the fantasy that visibility and existence are the same thing. It has taken away the fantasy that the vacuum is obviously just nothing. It has taken away the fantasy that solidity, locality, and common sense scale upward into cosmic truth without damage. But in taking those away, it has revealed a different dignity. A dignity rooted not in permanence, but in temporary lucidity. We live in a period of cosmic history where the universe is still readable. We live in a phase where stars still burn, free energy still flows, and distant galaxies still send ancient photons into our detectors. We live in an era where the background radiation of the early universe is still measurable, where the archive of deep time has not yet been fully redshifted into practical oblivion, where minds made of matter can still piece together the story of the stage on which they briefly exist. That is astonishing. The universe is severe enough to contain horizons, singularities, thermodynamic ruin, and perhaps hidden metastability. Yet it is also ordered enough, for now, to let local pockets of chemistry grow into biology and local pockets of biology grow into thought. Thought then looks outward and discovers not reassurance, but structure. A structure more indifferent, more exact, and in some ways more haunting than the old stories ever prepared us for. Black holes were the first great public symbol of that haunting because they were the easiest to see. They were visible terror. But visible terror was only the introduction. The deeper lesson is that reality's greatest dangers may be invisible revisions. Revisions to what can remain connected. Revisions to what can remain observable. Revisions to what can remain energetically possible. Revisions to what can remain stable under the laws we currently know. Revisions to whether our descriptive frameworks are final or only temporary bridges across deeper unknowns. That is what may be worse than black holes. Not merely a stronger force. Not merely a larger collapse. Not merely a darker region. A universe in which relation can be severed without destruction, evidence can be lost without deceit, structure can be exhausted without violence, and the very floor beneath ordinary law may be less final than our instincts assumed. Black holes still matter immensely. They remain among the most important objects in physics and among the most extraordinary natural phenomena ever understood. But if tonight has shown anything, it is that black holes may not be the last word in cosmic horror. They may be the most photogenic member of a darker family. A family whose members do not always look like objects. A family whose deepest representatives are conditions. A family whose signature is not always destruction, but the withdrawal of possibility. That phrase deserves to stay with you. The withdrawal of possibility. Not only the possibility of travel. The possibility of communication. The possibility of future causal reunion. The possibility of persistent free energy-rich complexity. The possibility that our current laws are complete in the regimes where existence becomes most extreme. The possibility, perhaps, that what we take to be stable is stable in the strongest sense. And yet there is one final mercy. The same physics that reveals these threats also reveals the astonishing fact that, for now, the universe has not yet withdrawn everything it could. There is still relation. There is still evidence. There is still light arriving from ancient distances. There is still enough lawful continuity for minds to discover what threatens continuity. That is where we stand. Not safe. Not doomed in any cartoon sense. Not standing before a single final monster. Standing instead inside a lawful cosmos whose deepest risks are written into the same structure that made stars, atoms, gradients, memory, and thought possible. Perhaps that is why the most mature emotional response to modern physics is neither optimism nor panic. It is lucid awe. Awe that the universe is intelligible enough to reveal its own dangers. Awe that danger can take forms more abstract than myth ever imagined. Awe that existence is not guaranteed to remain shared, legible, or meaning-friendly forever, and yet here we are, in one of the eras where it still is. So if you want the shortest possible answer to the question this title asks, it is this. What may be worse than black holes is not one hidden thing in deep space. It is the possibility that the deepest threats in reality are not objects at all. They are the rules, the limits, the conditions, the invisible ways the universe can stop supporting the kind of world in which explanation, relation, and complexity flourish. Black holes are terrifying because they show you the abyss. What may be worse is everything that does not. Everything that does not glow. Everything that does not roar. Everything that does not offer the dignity of a visible border. Everything that simply reduces the space of what can still be shared, still be known, still be structured, still be told. That is the deeper horror. Not annihilation alone, but a universe that can make meaning harder by altering the conditions under which meaning survives. A universe whose deepest risks are built into the rules of existence themselves. And perhaps more frightening because of that. Before we end completely, hold one last image in your mind. Not a black hole. Not a collapsing star. Not a spiral galaxy being torn apart. Imagine instead a quiet night sky in an unimaginably distant future. A sky with fewer external galaxies visible than ours. A sky with weaker clues. A sky whose old background light has thinned into near unreachability. A sky over a civilization, if any such civilization still exists, trying to reconstruct a larger universe. From a much smaller archive. Imagine what it would mean to live there. To suspect that reality is bigger than what remains observable, but to possess fewer and fewer ways to prove it. To inherit local law without easy access to cosmic history. To know stars and atoms perhaps brilliantly, and yet have the wider architecture of the cosmos. Hidden not by conspiracy, not by violence, but by time, redshift, and horizon. That future observer, if one ever exists, would not stand in a world of dramatic monsters. They would stand in the aftermath of structural withdrawal. And from their point of view, black holes might still be visible in some limited sense as extreme local objects, but the truly severe fact would be larger, the universe would have become less available to understanding than it is for us now. That possibility should change how we hear the present. Right now, the cosmos is still unusually talkative. Ancient light still arrives. Distant structure still leaves measurable traces. The thermodynamic engines of stars still run across huge volumes of space. The horizon has not yet tightened into its coldest form. The archive is still open enough for a species on an ordinary rocky planet to ask questions once reserved for myth. There is something almost heartbreaking in that generosity. Because it means that knowledge is not just a triumph of intelligence. It is also a privilege of timing. We did not choose to be born into a universe whose evidence is still available. We did not arrange the value of the cosmological constant, the age of stars, the transparency of space, the survival of gradients, or the persistence of relic radiation. But we are here while enough of it remains. That should produce humility. And maybe urgency too. Not panic. Not sensationalism. But urgency in the intellectual sense. To understand while understanding is still unusually possible. To study a cosmos that may not remain this legible forever. To recognize that what we call reality is not simply a pile of objects but a temporary accessibility. Structure held open by law, history, energy, and causal contact. And that is why this entire subject, for all its darkness, is not finally nihilistic. It is clarifying. Because once you see that the deepest dangers are structural, you also see that the deepest goods are structural. Connection is structural. Memory is structural. Explanation is structural. Shared world is structural. Complexity is structural. The conditions for wonder are structural. The universe does not guarantee those forever. But for now it allows them. And perhaps that is the most precise emotional conclusion physics can offer. Not that we are safe. Not that we are doomed. Not that there is one final horror waiting behind the next horizon. But that we live inside a brief and astonishing window in which reality is still rich enough, stable enough, and connected enough for a portion of itself to look out into the dark and ask what the dark is made of. Black holes were one answer. A profound one. But they were not the final one. The final answer, or as close as science can currently bring us, is harsher and quieter. What may be worse than black holes is a universe that can slowly, lawfully, and sometimes invisibly withdraw the very conditions that made black holes, stars, observers, and explanation possible in the first place.